It is unusual to find a knob and tube circuit wired in a loop configuration. Typically, knob and tube wiring installations are arranged in a radial fashion, meaning that power originates from a central distribution point, such as a fuse box or circuit breaker panel, and then extends outwards in individual circuits to supply various lighting fixtures, outlets, and other electrical loads. This radial design ensures that each circuit is isolated and protected by its own overcurrent protection device, such as a fuse or circuit breaker. In this configuration, if you were to disconnect the wires of a standard knob and tube circuit, you would typically find that only one side of the cut is energized, representing the incoming power feed from the distribution panel. The other side of the cut would be de-energized, indicating the portion of the circuit leading to the electrical loads. The situation where both sides of the cut wires are found to be energized, as described, suggests that the circuit may be wired in a loop or that there is an unintended connection or fault condition present. Several possible explanations could account for this unusual finding. Firstly, it is conceivable that the circuit was originally wired in a loop configuration. Although uncommon, it is possible that an electrician, perhaps in an older installation, created a loop circuit where the wiring extends from the power source, passes through multiple loads, and then returns to the same power source, effectively forming a continuous loop. In such a scenario, disconnecting the wire at any point would result in both sides of the cut remaining energized, as the current can flow in either direction around the loop. Secondly, it is possible that the loop was unintentionally created due to modifications or alterations to the original wiring. Over time, electrical systems may undergo renovations, additions, or repairs, during which the wiring may be altered or extended. It is conceivable that during such modifications, the original radial circuit was inadvertently converted into a loop, perhaps by connecting the end of one circuit to another. This unintended connection would create a parallel path for the current, resulting in both sides of the cut wire remaining energized. Thirdly, the presence of energized wires on both sides of the cut could indicate a wiring error, such as a cross connection or a short circuit. A cross connection occurs when the hot and neutral wires are inadvertently reversed or connected to each other. This can happen due to incorrect wiring during installation or repairs, or due to damage to the wiring insulation. A short circuit, on the other hand, occurs when the hot wire comes into direct contact with a grounded surface or a neutral wire, creating a low resistance path for the current to flow. Either of these wiring errors could result in the presence of voltage on both sides of the cut wire. Fourthly, the presence of a backfeed from another circuit is a possibility. A backfeed occurs when voltage from a separate circuit inadvertently enters the circuit in question. This can happen if two circuits share a common neutral wire, or if there is a fault condition that allows voltage to leak from one circuit to another. In this case, the voltage from the backfeeding circuit could be causing both sides of the cut wire to appear energized. Given the unusual nature of this finding and the potential safety hazards involved, it is strongly recommended that a qualified and licensed electrician be consulted to thoroughly inspect the wiring and determine the exact cause of the problem. A qualified electrician has the training, experience, and tools necessary to safely diagnose and repair electrical issues. The electrician will perform a comprehensive inspection of the circuit, tracing the wiring to identify any unintended loops, cross connections, short circuits, or backfeeds. They will also check the condition of the wiring insulation and the integrity of the connections to ensure that there are no potential hazards. Based on their findings, the electrician will recommend the appropriate repairs or modifications to correct the wiring and ensure the safety of the electrical system. It is crucial to address this issue promptly to prevent potential electrical shocks, fire hazards, and damage to electrical appliances. Ignoring the problem or attempting to repair it without proper knowledge and expertise could lead to serious consequences. Knob and tube wiring is an outdated wiring method that was commonly used in homes built before the mid-20th century. It consists of single insulated wires supported by porcelain knobs and run through porcelain tubes where they pass through wooden framing members. While knob and tube wiring can be safe if properly installed and maintained, it also has several inherent limitations and potential hazards. One of the main concerns with knob and tube wiring is its lack of a grounding conductor. In modern electrical systems, a grounding conductor provides a low resistance path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Knob and tube wiring does not have a dedicated grounding conductor, which means that in the event of a fault, the fault current may not be effectively cleared, increasing the risk of electrical shock or fire. Another concern with knob and tube wiring is the deterioration of the insulation over time. The rubber or cloth insulation used in knob and tube wiring can become brittle and cracked with age, exposing the bare conductors. This can create a risk of electrical shock or fire, especially if the wiring is exposed to moisture or physical damage. Additionally, knob and tube wiring is often overloaded in modern homes due to the increased demand for electricity. The original circuits were designed to handle a much lower electrical load than what is typically used today. Overloading the wiring can cause it to overheat, increasing the risk of fire. For these reasons, it is often recommended to replace knob and tube wiring with modern wiring methods such as non-metallic sheath cable, also known as Romex. Romex cable includes a grounding conductor and has a durable plastic insulation that is less prone to deterioration. Replacing knob and tube wiring can significantly improve the safety and reliability of the electrical system. When replacing knob and tube wiring, it is important to follow all applicable electrical codes and safety regulations. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Some key considerations when replacing knob and tube wiring include obtaining the necessary permits, hiring a qualified electrician, using appropriate wiring methods and materials, and ensuring that all connections are properly made and protected. It is also important to properly dispose of the old knob and tube wiring in accordance with local regulations. In summary, discovering a knob and tube circuit wired in a loop is an unusual finding that warrants further investigation by a qualified electrician. The presence of energized wires on both sides of the cut wire could indicate a wiring error, an unintended loop, or a backfeed from another circuit. A qualified electrician can accurately diagnose the problem and recommend the appropriate repairs or modifications to ensure the safety and reliability of the electrical system. Given the age and limitations of knob and tube wiring, it is often recommended to replace it with modern wiring methods to improve the overall safety of the electrical system. Here's a further explanation of several factors relating to knob and tube wiring and why a loop is unusual. Firstly, we consider the typical radial configuration. Standard knob and tube circuits are designed in a radial, or tree-like, configuration. Power originates from the electrical panel and feeds outward to individual loads. This means that each outlet or light fixture is connected to the power source via a single, dedicated pathway. Cutting the wire in a radial circuit should only result in one side being hot because you've interrupted the single path from the power source. Secondly, the absence of a ground wire means tracing faults is difficult. Knob and tube wiring lacks a dedicated ground wire, making it harder to detect and clear faults. In modern wiring, a ground wire provides a safe path for electricity in case of a short circuit causing a breaker to trip. Without a ground, a fault can energize unexpected parts of the circuit, potentially contributing to both sides of a cut wire being hot. Thirdly, consider modifications and alterations over time. Older homes with knob and tube wiring often undergo renovations, repairs, or additions. These modifications can unintentionally create loops or parallel paths in the wiring. It's possible that at some point, a connection was made that inadvertently created a loop, causing power to flow in both directions. Fourthly, examine the possibility of shared neutrals. In some older installations, multiple circuits may share a neutral wire. This practice, while sometimes acceptable under specific conditions, can cause unexpected voltage readings and potentially energize both sides of a cut wire if there are imbalances in the loads on the shared neutral. Fifthly, there may be backfeeds from other circuits. A backfeed occurs when voltage from another circuit enters the circuit in question. This can happen due to wiring errors, shared neutrals, or faulty appliances. If another circuit is backfeeding into the knob and tube circuit, it could cause both sides of the cut wire to appear hot. Sixthly, consider the age and condition of the wiring. Knob and tube wiring is old, and the insulation can degrade over time. Damaged insulation can lead to shorts or leakage currents, which could contribute to the unexpected voltage readings. Additionally, loose connections or corroded terminals can also cause problems. Seventhly, improper or DIY repairs are a possibility. Previous repairs or modifications to the wiring may have been done incorrectly, leading to the creation of a loop or other wiring errors. Eighthly, you need to use proper testing equipment and methods. Using a non-contact voltage tester or a multimeter can help identify energized wires. However, it's important to use these tools correctly and safely. A wiggy or solenoid voltage tester can provide a more reliable indication of voltage presence than a non-contact tester. Ninthly, the importance of professional inspection cannot be overstated. Given the potential hazards associated with knob and tube wiring, it's essential to have the circuit inspected by a qualified electrician. They can trace the wiring, identify any faults, and recommend appropriate repairs or upgrades. Finally, consider the potential for hidden junction boxes. Sometimes hidden junction boxes are buried in walls or ceilings. These boxes may contain splices or connections that could be contributing to the problem. Here are a few more points to consider when encountering unusual wiring configurations like a loop in a knob and tube system. Firstly, confirm the voltage readings. Use a calibrated multimeter to accurately measure the voltage between each side of the cut wire and a known good ground. Also, measure the voltage between the two cut wires. These measurements will help determine the nature of the problem. Secondly, trace the wiring path. Carefully trace the wiring path from the electrical panel to the point where the wires were cut. Look for any signs of modifications, splices, or damage. Pay attention to how the wires are routed and whether they pass through any junction boxes. Thirdly, inspect junction boxes. Open any accessible junction boxes in the circuit and inspect the connections for looseness, corrosion, or improper wiring. Make sure all connections are secure and properly insulated. Fourthly, check for shared neutrals. If multiple circuits are present, check whether they share a common neutral wire. If so, disconnect the neutral wire from each circuit and measure the voltage between the neutral wire and a known good ground. If there is voltage present, it indicates a potential problem with the neutral wiring. Fifthly, perform an insulation resistance test. Use a megometer, also known as a megger, to measure the insulation resistance of the wiring. This test can help identify any insulation breakdown or leakage currents. A low insulation resistance reading indicates a potential problem with the wiring insulation. Sixthly, identify all loads on the circuit. Make a list of all the lights, outlets, and appliances that are connected to the circuit. This will help determine the total load and the circuit and whether it is being overloaded. Seventhly, examine the electrical panel. Inspect the electrical panel for any signs of damage, corrosion, or improper wiring. Make sure all circuit breakers are properly sized and functioning correctly. Eighthly, check for evidence of rodents or pests. Rodents and other pests can damage electrical wiring by gnawing on the insulation. Look for any signs of rodent droppings, gnaw marks, or damaged wiring. Ninthly, consider the age of the wiring. Knob and tube wiring is old and may be nearing the end of its service life. The insulation can become brittle and cracked over time, increasing the risk of electrical shock or fire. Tenthly, document all findings. Keep a detailed record of all your findings, including voltage readings, wiring diagrams, and photographs. This documentation will be helpful for the electrician who performs the repair. Given that knob and tube wiring is an older system, it is essential to understand its specific characteristics and potential issues. Firstly, understand the basic components. Knob and tube wiring consists of single insulated conductors run through walls and ceilings supported by porcelain knobs and tubes. The knobs keep the wires separated from the building structure, while the tubes protect the wires where they pass through framing members. Secondly, appreciate the absence of a ground wire. One of the main differences between knob and tube wiring and modern wiring is the lack of a dedicated ground wire. This means that in the event of a fault, there is no low resistance path for the current to flow back to the source, increasing the risk of electrical shock or fire. Thirdly, consider the insulation type and condition. The insulation on knob and tube wiring is typically made of rubber or cloth. Over time, this insulation can become brittle, cracked, or damaged, exposing the bare conductors. Fourthly, be aware of the ampacity limitations. Knob and tube wiring has a limited ampacity, which means it can only safely carry a certain amount of current. Overloading the wiring can cause it to overheat, increasing the risk of fire. Fifthly, recognize the potential for overheating. Knob and tube wiring is designed to dissipate heat into the surrounding air. If the wiring is covered with insulation or other materials, it can overheat and become a fire hazard. Sixthly, respect the clearance requirements. Knob and tube wiring must be installed with adequate clearance from combustible materials. This is to prevent the wiring from overheating and causing a fire. Seventhly, understand the splicing methods. Splices in knob and tube wiring must be made in approved junction boxes using appropriate connectors. Improper splices can create a fire hazard. Eighthly, recognize the potential for insulation damage. The insulation on knob and tube wiring can be damaged by rodents, pests, or physical contact. Damaged insulation can create a risk of electrical shock or fire. Ninthly, consider the impact of renovations. Renovations or modifications to a building can damage or alter the knob and tube wiring, creating a safety hazard. Tenthly, understand the code requirements. The National Electrical Code, or NEC, has specific requirements for knob and tube wiring. These requirements must be followed to ensure the safety of the electrical system. Given the potential hazards associated with knob and tube wiring, it is often recommended to replace it with modern wiring methods. However, if the wiring is in good condition and meets all applicable code requirements, it may be possible to leave it in place. In this case, it is important to have the wiring inspected regularly by a qualified electrician to ensure that it is safe and functioning properly. The electrician should check for any signs of damage, overheating, or improper wiring. They should also test the insulation resistance and ampacity of the wiring. If any problems are found, they should be corrected promptly. Also, consider that insurance companies may have specific requirements for homes with knob and tube wiring. Some insurance companies may require that the wiring be replaced before they will provide coverage. Others may charge higher premiums for homes with knob and tube wiring. It is important to check with your insurance company to determine their specific requirements. If you decide to replace your knob and tube wiring, it is important to hire a qualified electrician who is experienced in this type of work. Replacing knob and tube wiring can be a complex and challenging task, and it is important to do it correctly to ensure the safety of your home. The electrician should obtain all necessary permits and follow all applicable code requirements. They should also use appropriate wiring methods and materials. Once the new wiring is installed, the electrician should test it to ensure that it is functioning properly. They should also provide you with a written report of their work. Replacing knob and tube wiring can be a significant investment, but it is an investment that can pay off in terms of safety and peace of mind. By replacing your knob and tube wiring, you can reduce the risk of electrical shock, fire, and other hazards. You can also improve the reliability and performance of your electrical system. In addition to the points already discussed, it's crucial to understand the historical context of knob and tube wiring. Firstly, it was an early standardization. Knob and tube wiring represented an early attempt at standardizing electrical installations. Before its widespread adoption, electrical wiring practices were often haphazard and unsafe. Secondly, materials limitations existed. The materials available at the time, such as rubber and cloth insulation, had limitations in terms of durability and resistance to heat and moisture. Thirdly, it was designed for low power consumption. Knob and tube systems were designed for the lower electrical demands of the early 20th century. Modern homes with numerous appliances and electronics place a much greater load on the electrical system. Fourthly, installation practices varied. The quality of knob and tube installations varied depending on the skill and knowledge of the electrician. Some installations were done meticulously, while others were poorly executed. Fifthly, it has a limited capacity for expansion. Adding new circuits or outlets to a knob and tube system can be challenging and may require extensive modifications to the existing wiring. Sixthly, there are concerns about asbestos. Some older knob and tube wiring may contain asbestos, a hazardous material that can pose health risks if disturbed. Seventhly, there is a lack of overcurrent protection. In some knob and tube installations, the overcurrent protection, such as fuses, may be inadequate or improperly sized, increasing the risk of fire. Eighthly, it may not meet modern safety standards. Knob and tube wiring may not meet all of the safety standards that are required by modern electrical codes. Ninthly, it has an impact on home value. The presence of knob and tube wiring can negatively impact the value of a home, as many buyers are wary of the potential safety hazards and the cost of replacement. Tenthly, it is important to disclose its presence. If you are selling a home with knob and tube wiring, it is important to disclose this information to potential buyers. This will allow them to make an informed decision about whether to purchase the property. In conclusion, while knob and tube wiring may have been acceptable in its time, it is generally not considered to be a safe or reliable wiring method by today's standards. If you have knob and tube wiring in your home, it is important to have it inspected by a qualified electrician and to consider replacing it with modern wiring methods.